Oh, MZ. So, hi guys, welcome to High Stream. And today, High Stream? What is it? I'm so sorry. Actually, I'm little. I got so excited. Welcome to High Entropy. And today is day 67 of DSA learning. And I generated one thumbnail from using ChatGPT, you can say. Now I will paste it. And what we are going to do. So today I'm not targeting any number of hours. At least I have to practice till 7. I don't know how many problems I'm gonna solve, but I will solve till 7 or just a few minutes earlier to 7 because I have to jump to a call. Because I noticed today I failed two exams and I know how it feels when you fail the exam. And after that, it's like you are living in delusion. And then I got to know, okay, things are not in the right way. You have to practice lot. So now you will see lot more streams, and without any time foundation I'm gonna fuck everything until things won't be in the right track. So I'm little too excited, but yeah. So let's start. I hope stream is started, and I kept fan on because the reason is simple. It's too hot fan. If I will turn off it for maybe any time foundation, I'm gonna fuck everything until. So it will be very horrible in the right track. So hi guys, little too excited, but welcome to hi. So entropy. Let's start. I hope energy should be high, and I kept fan on because the reason is simple. It's too hot. If I will turn off it for maybe join foundation, I'm gonna fuck you can join my Discord. So it will be very horrible in the right track. So hi. I have to. I can mute it. I tried. I don't know why I'm not muting it. Okay. You have any query or suggestion? Do let me know. Let me know. Okay, I don't know. Don't know is the big enemy of no. Take you forward. Let's jump and solve the DSA problem. Boom, 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 boom. Yesterday I skipped AI. Yesterday I skipped English speaking, both things, and the reason was simple. I was preparing for DP 700 and crazy. I thought I will crack it in the 2 days, within 2 days, but unfortunately I couldn't. And the same happens with life. So, okay, distinct subsequences. Let's look into this problem. Given to a string s1, no. Why they kept name t and s? Okay, forget about it. Given to a string s and t, return the number of distinct subsequences of s that equals to t. That equal t. A subsequence of a string is a new string generated from the original string with some characters can be none deleted without changing the relative order of the remaining characters. For example, ACE is a subsequence of ABCDE while AEC is not. 1 minute. ACE is a subsequence of ABCD ACE while AEC is not. Yeah. The task is to count how many different ways we can form T from S. Deleting some or no characters from S, return the result modulo 10 to the power 9 plus 7. Okay, so first thing is we need to find the. Oh, let's write it down. I don't know, man. We are gonna solve it. I just got this intuition like what exactly needs to be done. I mean, I got the requirement. Solve it on paper too. Okay, let me solve it. So we have S1, you can say, or S, let's keep S. AX, BXA. This is one string. T will be nothing but AXA. Okay, we have two strings. And let me note down another one. BA, BG, BAZ. I can see some substring over it. Now I got intuition. I mean, why there could be multiple strings. It's not like only one possible. Uh, where is my quick time player, bro? Oh, why are you showing my face? I am not beautiful. I mean, I am not handsome. Beautiful issues for girls. Hey, girls. I know. Okay, function. Sorry, jokes apart. Okay, we have this string. So this our target question says you have to find this subsequence in this one and find how many different subsequences you can form from this. This okay. Got it. Got it or not got it? Okay, so our goal is simple. We need to find the longest common sequence subsequence in the between these two strings. Simple. And longest common subsequence earlier we used to find. Now we need to find this sequence in this one. Simple. So this is the goal. Our goal is like if we can find this sequence in S, and this will be the longest, longest common subsequence LCS, because this is the length of it, and maximum length that you can get between two strings is like you are getting the shortest. Like if there are two string S and T and you wanted to find what is the maximum possible longest common subsequence between these two, the length of the shortest string, right? So length of this one, and here goal is find the length of the shortest string. But so actually we need to find it inside it. So normally what we were doing, suppose I need to find out between these two. Let's say AXBXA, and there is another string AXA. What we used to do, we'll start from this one and we'll start from this one, matching. Then what we'll do, oh, it's matching, simply you will say okay -1 and you will move to this one and this one, you will say okay, it's also matching, good. So you can say like okay, right now we have AX, okay, now you will say B and A are not matching, so I will take one of either of them. So for example, here I'm considering B, not considering A. Then you will say okay, string is not matching, so far you got, so you will get smaller length. Now you will say okay, no problem, from here how much length you are getting. So there will be like AXB and nothing. Another option will be, you will say AXB, you removed B, I mean from first string you are skipping one, and here you're keeping A. So again it is not matching, so you will say AX one option and empty. Another is like here you will say what I'm keeping, AX and blank. Another is A and A. So this is one option. So you will say, okay, I got AXA. But the problem, it's also there are other possible options. So I cannot say AXA. Huh. How can I approach? So there are two, right? Okay. Okay, so there are right now what we are doing. Our goal was simply find the LCS. So find LCS. In LCS case, like our goal was simply we need to find the longest common subsequence. So every time when something is matching, that means definitely this will be part of it. So once it is part of it, then that means it's not going to. But here we need to find out. I mean, what I wanted to say. In normal approach, what do you do? If you don't have to find the LCS, longest common subsequence, you have to find all possible options. That means you are gonna try out, right? For example, here this A you matched and removed. Okay, this is one option. But what if there is another option? This A will match with something else. So that is also possible, right? And this A will match with something else here. So this is also possible, right? Okay, just thinking. Hmm. No, 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 it won't work. AXB. Let me write down all the other AXBXA, AXA, AXBXA, and AXA. So at starting, you will have to. These two are strings that we are at starting. Now, what are the options? A is matching. So there will be two options. One is you consider it. So now you will say AXBXA, BX, and here AX. Another option, you consider AXBX, okay, and you are keeping this AXA. Third option, AXBXA and AX. Is it right approach if I'll say AX? This option will be like when you are removing it. So it's wrong, right? Because we need to consider all the character from it. Then only subsequence will be formed. Otherwise, it will be like a part of it you are trying to match. But our goal is to find. Okay, okay. I think this won't be the right one. So now I have two options. What I'll do now, I'll match x and x. It is matching. If it is matching, then we have two options: ax b and a. Another is like this is matching, but you will take ax b and here you are keeping ax. Now you will say axb. Okay, now you have other two options. A and b are not matching, so you will say axb axb. Okay, every time you have to discard from the first string, second you wanted to keep the complete string. Okay, so axb you will keep, no, so you will remove a x from the top and a not matching, then you this will be the case and another case won't be there. And if it is not, then you will say okay, now I have two options or I have one option only. You will say a and from here a, so you will say okay, it's matching, so you will say 1 a you are getting from here, and from here you will say what you are getting, not matching, so a only. From here you will say, by the way we want just count, right? So you will say okay, you will say 1 from here you getting, and if you are getting from anywhere where else, no. So okay, you will return 1. Now you will say okay, from here you are returning 1 and 1. Now you need to check from here 1, and from here you will again explore. Now right now you have ax and axb, so you will say x and b are not matching, so you will say okay, discard b and ax, this one won't work here because we want keep this string as it is intact. So okay, now you will say ax, so matching, so there are two options. If it is matching, so you will keep ax and a, I mean you will do two things, a x you remove from both. Otherwise if you are not taking x, then it will become a and ax. And now again you will say okay, not matching, that means you will remove a and it will return 0. So from here 0 0, and from here it will match, so it will return 1 and 0 both sides, so it will, you will return 1 to it, and it is gonna return 1 to it. So here you will return 2 from this branch, and from this branch you will say okay, ax ax b, and you will okay, now you have different options, so you will remove this one. Okay, so ax b and ax a, now this is the option. Now you will say okay, no problem, b and a not matching, then you will say remove b, ax and ax a. Now you will say x and a not matching, so remove ax, I mean remove a x a and a matching, then there are two options, either take it, so if you take it then it will become blank string, and ax, that's not possible. And another option here, what, okay, another option is where you discarded a from both ends, so it will become, oh you already discard, so you are keeping for a blank and axa, so here 0 0 0 0 0, and here you will return 0 0, and then it will be like 0 0. So finally you will say okay, 2 I am getting, but it's not enough. I got intuition, but dry run is very important. I learned something from today's failure. Failure. Failure or failure? Failure. Yeah, failure. We have another string BA, BG, BAG. BA, B, BAB, GBAG. I just wanted to see BAB, GBAG, and second is BAZ. Okay, so these are the two strings we have. So now, first thing, okay, I will tell you what is now. I can tell it to you. If S1, if S of I minus 1, let's say S of I equals to T of J. That means last character is matching. If you have to find out LCS, then what you will do? You will say, okay, keep it and move further and find remaining part. But here it could be like this is matching. This is one thing, but you need to find out other options. So what are the other options? For here, from here, you know, you are sure like you need to find out the complete string. You are not looking for sub part of it or contiguous sub part of it that is matching. That will be another scenario. So you will be having two options. Okay, option one, you are just keeping from both. If you are keeping from both sides, then you can sort the length. Okay, you got one element from both. But if you are not taking, like there are three options. Either you can take from both, you can take from like one string and you are keeping from another. But here in the another option, or you can say, okay, I mean I'm let me try to articulate it again. So suppose this is I, okay, this is I, and this is jth index. Now what are the options? You can say first thing is G is matching between these two, so you will sort the length. Now you will be having this string and this one, and you need to find, because you found the one subsequence or one character, it is matching between these. So now you have to look for further. Another option, you can say like, okay, this is matching with this, but there is other chances. If you see, it could be like it is matching, gonna match with this one. If you see BAG, we can form. So in future it can match. So you will say, okay, I won't consider this one. That is another option if I can get it. So you will say option one. What you will say? Simply you will do I minus 1. I minus 1. That means you are discarding this character. You are looking for the same character in a substring, sub part of it. And option 2, I minus 1 and J minus 1. I mean, this is not syntax. So you can say, okay, let me do it like this. OP1, comment I am just adding. So I equals to I minus 1. And option 2, I equals to I minus 1 and J equals to J minus 1. These are the two things that you have to do. Okay, that's all. Now let me dry run it. Then you will get, I mean, I get it more for intuition behind it. So right now, okay, I will remove it from here. Now I have BAG. So what I'll do, first thing, I will consider both. So now it will become BA, BG, BA and BA from both. Here you will see BABZ, BA and BAZ. These are two strings, right? So first let's explore the left part where you considered this. Now again you got these two matching. So you will say, okay, it's matching. Then I will say it will become BABZ, B and B. And another one option you will explore here. You will say, okay, BAB, Z, B and BA. You discarded this one. Now you will say, okay, no problem. B and B matching. So if it is matching, then you will say, okay, BABG, and here you will be winning nothing. And the second option, what do? You will say BABZ and B. Now it is not matching. So if it is not matching, okay, I forgot. Sorry, I forgot. else option. Else means you have to discard from first element. So I equals to I minus 1, because you are looking for the last element, you want to find out pair for it definitely, so you cannot discard that. That is one thing. Now you will say okay, b and g not matching, so you will say okay, no problem, I have only one option, b and b will remain here. Now you will say okay, it is matching, then I have two options. First option, I will keep remove from both ba and b, I mean ba and this blank. Another, you will say okay, I will keep ba and this. So here also you will say this is done. Okay, so now you will say okay, b and a not matching, then b and b, because this is not matching, that means you will remove this character, right? Now both are matching, so you will say from this and this. If you won't take this, there will be another option like okay, not taking, then b will remain same, this will become this. Now for let's look for this one. Oh, so many options are there, so let's explore it. How much time I took 26 minutes, no problem, bro. 1 hour 30 minutes. Okay, so now we have two approaches, two ups. Like here we have two options or one option only. B and B not matching. That means you will discard B. So you will say B A B. We don't have any options here. B A B Z and B A. Okay. Now you further A and G are not matching. So you will say B A B and B A. Okay, now you will say B and A are not matching, so you will say BA, and here you will say BA. Now you will say okay, both are matching, then I have two options. First, remove from both, then B and B will become, and if you are removing one, then it will become B and BA. So now you will say okay, if B and B are matching, then you will say okay, I just writing, you will say B blank 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 blank. Another option, here you will get blank, here you will get B. Here you will say okay, B and A not matching, then you will say blank and B A. These are options. Okay, now I will explore further another branch. G and A not matching, then that means BA, BZ, B and BA, because BAG, sorry, A and G not matching, then you will discard A. Now again it's not matching B and G, then BA, B, Z, and you will remove and BAZ. G and G is matching, then you have two options. You can remove from both sides, or you will reduce the, so BA, B and BA, this is option. Another, you are removing from this one, S, you can say BA, B and BAZ. Okay, now let's explore this one. So you will say BAB, B and A you are removing. So I'm removing B and A. I mean B is not matching with this, that means simple, there will be only one option, BA and BA. And here you can say, I'm just not writing it, you can get it from here, like you will say you will be having two options, so you will get only one option. Okay, from here you can say you will get 0. I'm just not writing exploring it, but from here you can say, so I will just write down complete string. So here you will go to this, so from here you will get 0, from here you will get 0. Really? You will get 0. Wow. Here if a string has to become empty, that means you are able to form it. So you will say 1. Here you will return 1. From here you will return 0. Here you will return 1. So you will get 1 1. So total 2 2 3 3. Here you are going to explore this branch. I mean not this one. Okay, 1 0 1, and now you will say 1 1 and 1 1. So total 4. Here you will say, if are you getting anywhere? From here 1 1, and you will say 1 1 5. Now I need to find the LCS max count, and if I'll use that old approach, I mean dictionary. What are you saying, bro? It's bad. So I was saying, if I'll use recursion, LCS was taking a lot of time and it's not feasible, or maybe no one is approaching this approach because it's complex and not optimal. That optimal. So I won't go with the LCS approach. Simply I will use, I mean recursion approach. I will use tabular approach because that is the right approach here when you are solving. But if someone will ask, I can tell them like, okay, this is way you can write recursion. So I have two conditions. First thing, let's write down the base condition 0 0. If any string is 0, what is the common between these two? Nothing, right? So you will say 0. Let me say BABAZ. BABZ. Who will write? I just got the intuition. I will do it directly. So simply, first thing, let me think about the base condition. What if one length of one string is 0? That means you will get 0 because nothing is common between these two. I want to check the constraints first. So what is the minimum length of? At least there will be one character. Okay. Hmm. So here we don't want length. Uh, I mean the count of character. So okay. So what do you want from it? S1 is equals to this. That means you will say okay. Give me the result. There are two options. Option one, you are considering character. Take from both. Leave it. Option two. Okay. Option two means you will say uh, not take from B, from S, and else not take from S. So here will be like one, because we want just to see count. It means if you don't have any length here, if I'll keep this one as one, will there be a problem? When you have empty, ST is empty, that means you are able to successfully match the character of T with some character of S. So you can say one. And for other, simply you are gonna say, so whatever you will get from this, so OP1 plus OP2, and here you will say OP1 only, not OP1, here OP only. So let me do one thing. I will create a table. Do I need to create full table, or can I solve it? What exactly here I need to do? Table of I and J is nothing but you are not taking. So table of I minus 1 you are not taking, and you are considering Z, or table of you are considering I minus 1 J minus 1, and here table of I minus 1 and J. That means previous, and this one is previous, previous only. So I can solve it using two options. So previous, let me say n is equals to len of s, and m is equals to, it's better I'll use m, and len of t for, okay, table is equals to, not table bro, previous is equals to for underscore in range n, number of columns n plus 1, and I will say 0 for each. I will use the same, I will copy the same, and I will make it current, and here I will keep 0 as well. Okay, maybe, well, let me keep it 0. Yeah, it's better I'll keep 0 everything. Then previous of 0 is equals to 0 equals to 1 for I in range 1 to n plus 1 m plus 1 for j in range so here first thing previous not previous is okay current of 0 I'm just initializing with 1 first when you have length of second string 0 then that means and now you will say current of I is equals to current of J is equals to if okay S of I minus 1 equals to D of J minus 1, that means both are matching. OP1 is nothing but previous of where you are keeping I minus 1, okay, and J will remain same. Oh, sorry, previous of J. Let me do it directly. Why do I need to use it? You will say current OP1, okay, better, it's better. Previous of J, OP2, previous of, it's better I'll use this like J minus 1, previous of J, and table current of J is equals to OP1 plus OP2, and else part means there you will say current of J is nothing but previous of Z, because you are on. Finally, after each current previous will be current and this one. Finally, you will return previous of n. But I have one doubt. What about the first value? Base condition, is it correct or? Let's say you have something. No, nothing is left in this array, and here you have something. In the first array, like you have A, B, C. What does it mean? You are already covered, so you will say 1. Previous is not defined. Oh. Come on, man. Okay, so I forgot one thing. Result should be mod of both. So mod percentage by mod. Done. Great. Edit distance. Hmm. Given to start and target. Oh, what is this? Edit distance. Given to string start and target, you need to determine. Given to string start and target, you need to determine the minimum length number of operations required to convert the string start into the string target. The operations you can use are: insert a character, add any single character at any position in the string, delete a character, remove any single character from the string, replace a character, change any single character in the string to another character. So, okay, so what are the number of operations that you can do? Total three. One you can delete, one you can insert, one you can replace. Okay, so out of three, you wanted to do minimum. Oh, no, no, no. I think I misunderstood. So insert a character, add a single any character at any position. So these are the operations that you can do, but you can do any number of times. I mean, yeah. Because if you are using delete, that means suppose you wanted to change it to, so there will be two options, like you will insert it first, you will delete, that is two operation count. But once you are replacing, replace is more optimal because you are just replacing a character with another character. Got it, but I don't know. I need to think about it. Okay, now let me note down the example. We have two examples. So what I'm thinking, there was one question similar to it, where we just need to find out the minimum number of operation to convert this string to this string, right? So our goal was, what was the problem? I forgot, man. It was similar to this, but only there was, I remember there wasn't any replace option, and convert a string to this one. Suppose I just have to find the number of. First thing you can say, what are the characters that are matching between these two in the same order. So longest, here you will say you will matching this and this. So where you will say these two characters you can remove, drop. So two operations. But it's always not the ideal scenario. Here you will say what is LCS, longest common subsequence. So you will say bro, A is matching with A. No, let's start from here. D is matching with D. E is matching with E. C is matching with C. And A is matching. So LCS is, I believe, 3. Z, there isn't any. D is there, but D if you match. Okay, you can match ACD or you can match AD. I mean ACE. So LCS is 3. That means you can match 3 character out of it. And what is our goal? To string start to string target. Bro, how will I explain it to someone? I'm getting into the same zone. No. Okay, so first thing is LCS. These are the characters that are common between these two. So you don't need to perform any operation between these two. And your goal is to convert S into T. Okay. So you will say, bro, I will find the AC. AC E. If I will keep AC, let's say AC E. Then what are the character between it? A, there is Z, E, there is 1. So here if you see between C and C, how many different characters are there? B. So okay, there is 1. That means you can use replace. What about other? AC and ACE. There is D. 1 delete. Okay. And what else you will do? And two other characters, F and G. You will say one replace C E A C E. 1 delete, 2 delete, delete. This is one option. And if you are taking A B, C, D, E, F, G, and here you are taking A, Z, C, E, D. Now you consider this one. From here A, from here C, from here D, you choose D and D. Now what are the corrective? First thing, you will say this is one thing and this is one not matching. So you will say B and C replace. Okay, C matching D and E. D. What are the characters between this? So this is my one thing that is missing. So you will say E is not there. So you will say add or insert. What are other options? D, E, and D, and after that you will say okay. What are the different options? E, F, G is remaining. So for E, F, G, definitely you have to do simply insert, delete. So if you notice, there are five. Here four. So four is the minimum. Now you need to check. Huh. I'm just thinking like, okay, what are the different options you can say? Common character. जो okay, so whatever the characters that are common between these two. So what I'll do, bro, I failed GP 700 and you are showing me a recommendation. What should I do? Doing tutorial, doing. Oh god, what the word? Mm-hmm. I was just thinking, like, do other people also think in the same way? Not in the same way. I mean, I just think what. Uh, I think I take a lot of time to think and come up, and I always forget what I thought. Maybe next time I have to think it again. So somewhere something is missing. I mean, whatever I solved, I will forget them. I will reattempt them. This is the process that's going away with me. Like it's the process that I used to do the same. And so if you guys know like how you approach to problem or how you approach a problem, do let me know, because I really feel like, am I doing in the right way, or there is something missing. The time that I'm taking to think about the problem, solution, and then yeah. EFZ, delete, what I do. Okay, what I'm thinking, our goal is simply to minimize it, right? So whenever I'm trying to find the LCS, so you will get LCS, right? For example, here you will get the count how many characters are matching between these two, this one and this one. So you can say like, okay, suppose here C and C are matching, let's say. Okay, now you proceed to the next character. Okay, this is matching, so I can take this. That is one option. Or you can say, hmm, I got little intuition. A B C D E F G, A Z C D. You know what? Like whenever we are at some particular character, there are multiple options, right? You can get LCS from that particular option. Maybe it's not matching. Then what are the options you have? You will say, okay, let me just trim down this one and this one. So you will say A B C D E and F. This is one option, and G you removed, and here you will say A Z C E D. You kept the same. So from here you removed Z. Okay. Now you will say, okay, no problem. Whatever we are getting from this, or you will say A B C D E F G, and you said okay A Z C E D. You will remove D. So now this is one option. So you remove minus D from it. Now whatever you are getting maximum, like you will say, okay, find the LCS from this, find LCS from this. Okay, and I mean from both string, whatever, not find the LCS. Basically you will say, okay, what is the LCS of it? Let's say something you got, let's say K. So what is the option like? So how many characters are there, how many characters are there, out of which how many are common? So K are common from the both, right? Okay, so what I will say, K characters are matching from this, K characters are matching from this. No,
Okay, out of let's say k matching, so the total length is n2 n1. So n1 minus k, n1 minus k characters are remaining between this, and n2 minus k characters are remaining between these. So you will say you can replace k characters. So let's say p, that is q. So p minus q. Whatever you are getting from this. No, bro, it's not going to help. I mean, p and q, the remaining character from this. Just do one thing. You will say I will get count from here. LCS count, and you will say D is still there. So D is you removed from D from here. That means you need to insert it here. So plus 1. No. Approach is not working, so let me do one thing. Park it. Park it for the time being. And jump to another problem. Wildcard matching. Now I feel I won't be able to solve it as well. Why don't I watch the tutorial?
So today we will be solving the famous problem edit distance, and this comes under the category of lead code hard. And yeah, we are continuing with DB on string. So this is a problem similar to string matching. So what is the problem? What does the problem say? You give a string s1, you give it a string s2. Okay, and there are three different operations you can do. One is something like you can take any word, any character, and insert anywhere in string s1. Okay. Next is remove, which means deletion. You can take any character and you can remove from s1. The third is replace, where you say, okay, pick up any character in string s1 and replace with any given character. And you're given these three operations. You're allowed to do these three operations. You have to tell me what are the minimum number of steps in which you can convert this given string s1 into this given string s2. That is what you just need to tell me. And if you're able to tell me that, that is what the question states, edit distance, which states minimum operations by using these three functions in order to convert the string s1 to string s2. In the previous videos, we have done a problem Now to convert S1 to S2 using these two functions, which was insert and delete. But now in this question, I add one more, replace, and that makes the question a bit harder than the previous one. So for an example, let's understand the question. You're given this horse and you want to convert this into this ROS. What is the minimum number of operations? So before finding out the minimum number of operations, let's understand, is it always possible? The answer to that is definitely. If you're asking me, is it always possible? The answer is very simple. Yes. How? Delete, 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 delete. Perform the number of deletions, empty string, use insert ROS, and you convert S1 to S2. So delete all, insert the string S2. So possible at maximum n plus n steps, rather, not big of n plus m steps is the max that you will take by deleting everything and then by inserting. Okay, so let's find the minimal one. So what I will do is, I will go across and say, okay, the first operation that I will do is, I will replace H with R, which makes it RORSE. This is what the string is. So the next operation will be, I will say, let's remove R, which makes it, at least this R is what I'm saying, which makes it ROSE. Next operation I'll say is, remove E, which makes it ROS. And this is nothing but the string S2. How many operations did I need? I needed 3 operations. You can try out all other ways and you'll not find any different combination where you can get into lesser number of operations. So 3 operations required. Did we use insert? No, we were done with replace and 2 removal operations, and we are able to convert this into this. Okay, so let's take one more example: intention and execution. Okay, so the first thing that I will do is, I'll say, okay, let's remove E, which makes it inention. Which makes it inention. I said let's remove this particular E, so I removed it, which makes it inention. Next I'll say, hey, can you please replace I with E? I'm saying replace this I with E. I-N-E-N, inention. Done. Next I'll say, let's replace N with X. This N with X. Remember, whenever I say replace one N, you can just replace one N. This becomes E-X-E-N, extension. Okay. Next I will say, replace N with C, which makes it E-X-C-T-I-O-N. I said, please replace this N with C. Perfect. Next I will say, can you please insert U? Where? Here. This becomes E-X-C-U-T-I-O-N. Thereby, this is the string S2. How many operations? 4 operations is what you required. 4 operations is what you required. And this is the minimal set of, or rather 5, my bad, 5. These are the minimal set of operations that you will require in order to convert this S1 into this particular S2. And you have to tell me this particular, like you have to solve this question only. So how do you solve this problem? You can say, we can go across the string matching path. Yeah, we know that's recursion, which is the string matching path, where we recursively try to match everything. So how do you do this? Let's take this example of ROS and HORSE. So this is the example that I have taken. So what you try to do is, you say, okay, this is E and this is S. So they're not matching. So if they're not matching, how can I match this S with E? One thing that I can think of is, I'll just take it off. Yeah, I'll say, I don't require this. Hey, let's delete it. So if I delete it, that's fine. Then we'll try to match HORS with ROS. So if I just tend to delete it, it's going to be off, right? And then we will be like, okay, this S matches with this S. Then I'll be like, fine, if this S matches with this S, we are pretty much done with first S first. Next I'll be like, okay, this is an S, this is an R, and this is an O. They're not matching. So I can be like, hey, what can I do? I'll be like, hey, let's delete it. So I'll try to delete it. So I'll be like, okay, let's omit this. Okay. Next I'll be like, okay, this O matches with this O. So I'm like, perfect, I got the second match. Next I can be like, this is an H, this is an R. I will like, okay, I need to make this S as an H as an R. Let's replace it. So just replace it. That's it. So I did match SOO, and since I'm replacing, this is also matched. Since I'm replacing, because if you're trying to replace, you'll try to replace it with R only, so that it gets matched. So this will match. So I'm getting an intuition that I have to do a kind of string matching, where I take character, like one character from the string S2, another character from string S1, and then try to compare them. If they're matching, it's well and good. If they're not matching, then I have a lot of options. So if they're not matching, what options do you have on your brain? Let's ask it to yourself. If they are not matching, because if they're matching, it's fine. Like for example, we had a match with O and O, it was fine. If they're not matching, what operations you can? You know, the operation that you can do is, you can say, I will do an insert of the same character. That's what I can think of. I'll try to do an insert of the same character. How? I'll tell that afterwards. If they're not matching, or I can say that, okay, I'll delete and try to match it on the back. Delete and try finding somewhere else. Or I'll be like, I'll try to replace and match. Similar to what we did here. This was not matching, so I tried to replace and they got matched. So I can insert the same character, I can delete and find in the string, or I can replace and match. These are the 3 operations that I can think during string matching. Right? So I know I have to try all possible ways, because I can either insert, I can either delete, I can either replace and match, I can do a lot of stuff. So if I'm trying to do all possible stuffs, I know among all these ways, I need to figure out what's the best. And that basically takes me to the place where I say try always. And whenever it comes as try always, you know what comes up? Recursion is the first thing that comes up. I'm gonna try everything. I'm gonna go across this, and it states minimum possible operations. Out of all these operations, whichever gives you the minimum, you just take it, right? So I'll be like, okay, try all possible ways, that's recursion. How do you write recursion? Because the first step is how to write recursion. So let's actually go back and try to write this recursion stuff. How to write recurrence, correct? So the question is ways about how to write recurrence. I can say there are two strings. So I'll try to express in terms of, as usual, our rules. In string matching is I represents the first string, J represents the second string. Explore all parts of matching. Explore all parts of matching or possibilities of matching. What are the questions stated? Give me the minimum number of operations. So I'll be like, return the minimal of all parts. Return the minimal of all parts. Okay, makes sense. Fourth is definitely the base case. Fourth is definitely the base case. There is no other thing that I can at least think of. So let's try to write the recurrence stuff. So I can be like, okay, I'll start with f of ij, and as usual, we'll write the base case afterwards. But we need to understand what does f of ij signify. So assuming it was horse and ROS, assume I is here, j is here, which means f of n minus 1 and m minus 1. What does this signify? This signifies find me the minimum operations to convert string s1, which is from 0 to I, to string s2, which is from 0 to j. That is what it signifies. From 0 to I, convert this into 0 to j. That's what it signifies. If I would have been here, convert HO to ROS. Got it? If J would have been here, I would have been here, convert HOR to RO. That is what f of ij signifies. So, what cases will be there? I know whenever we are doing string matching, there are always two possible set of cases. One is that they match, the other one is that they do not match. So, we'll write the basis afterwards. You know one thing, if they end up matching, yes, if they end up matching, it's a very common thing. If they are ending up matching, do we need to do anything else? Do we need to perform an operation to try to match them? The answer to that is no, straight away. For an example, if you're standing at this O and you're standing at this O, don't they matching? Why do you want to do an insert? Why do you want to do a delete? Why do you want to do a replace? There's absolutely no need of doing anything. So what you do is you say, hey listen, they're matching. So let's shrink the string and try to find the answer in the shrink string. So I'll be like, okay. So if they're matching, am I actually applying any number of steps? The answer to that is no, straight away. We are not applying. So I'll be like, if they're matching, hey listen, I'm not applying any set of steps. And my string also reduces to this. And now I try to find the answer. How many steps are in this reduced string? Because I and J have matched. So I'll try to see how many steps does this string take to convert into the string. That's what I'm doing. Perfect. What if they don't match? If this if is not executed, then it'll come over here, which is the else condition. What then? Then I know one thing for sure. Let's come on. If this E is not matching with this, what's the first thing that I can do? What if they don't match? If this if is not executed, then it'll come over here, which is the else condition. What then? Then I know one thing for sure. Let's come on. If this E is not matching with this, what's the first thing that I can do? Let's think. I can be like, okay, fine, listen. I can write an S, which is insert operation. I can just insert an S, and I say this S is matching with this S, right? I can say let me just write it. I'll write this S, and I'll move this J. And now I'll say this S matched with this S. But I'll keep the I here because hypothetically, I've tried to place this S right ahead of I. So that next I can compare this E and O. I hope that makes sense. So in an insertion, since hypothetically you're inserting an S right there, so the I is still at E because hypothetically you've entered an S. So I stays where it is because this S and this S has matched. But you do an insert operation which takes this S and is similar, and the J reduces. So I can say the replace operation is going to be very straightforward. I stays where it is and the J reduces by 1 because you have hypothetically inserted S, so they have matched. So I is still because someone got inserted right ahead of me. Why will I bother to move? I'll stay where it is. This S got matched, so J will get reduced. That is how you can do an insert operation. Perfect. So if you're doing this insert operation, that's one step. Can I do something else? Let's go back. Let's go back and see if I can do something else. Let's erase this. Can I do something else? Okay. What operations do I have? I have a delete operation, right? I'll say, hey, let's delete this. Let's take this and try to match this S with this S. I'll be like, let's delete this. Let's take this I here and now try to match this S with S. I'll try to delete it. So if I delete it, I'm saying, go. So I reduces. I will reduce. I'll be like, yeah, makes sense. So if I'm trying to delete it, can I say, only I reduces, and I'm again taking one step. I will reduce, and does the J reduce? No. You delete it, but you're still looking for this S. You deleted, but you're still looking for this S, which will get matched at the next step, Thereby, I all reduces, the J stays where it is. Perfect. What about the other one? So again, we will just go back and try to just write it again back. Yeah. Oh, where was I? I was here, right? We have a E, we have a S. What is the other thing? We have done insert, we have done the delete as well.
Replace.
The other thing is definitely replace, because that's the other operation remaining. If you're replacing, what else, like, will it make sense if you replace it with A? No. Why will you replace it with A? You're not a fool. Are you a fool? No. So you'll be like, what will I replace that with? I'll be like,
S.
okay, let's replace this with S, so that this S now matches with this S, and now I can look for in the remaining portion of the string, because in order to replace, I will try to match these guys. So replace will be done in that way. And after they are matched, I reduce both the strings. So like, okay, if you're trying to match, it's still replace operation is still one. And reduce both the strings. Perfect. You reduce both the strings. So these are the three operations that you will encounter if they are not matching. And by doing these three operations, you will somehow or the other try to match. And after that, you have to take the minimal of all of these three. And that's what you do. And that's how you can write all possibilities. Wow. Last thing, base case. What can be the base cases? Try to think. Try to think. Generally, the base case is when it's over. What did I say? Base cases when it's over. That's when you think of base cases, correct? So when it's over, what does that signify? You were comparing someone got exhausted. Someone would have got exhausted. Let's analyze what happens if string 1 gets exhausted. Let's analyze the other way when string 2 gets exhausted. Okay, so there can be two ways. Because I know one thing for sure, if I and j are somewhere over here, somewhere on a character, we can still do operations. But what if they don't have any characters? For example, we were at something like horse, right? Let's take a word as HORSE rather. And you came over here, which is the -1 index. This is where the I is, right? That is when I say string 1 gets exhausted, when I is over here. And you still are having a rows. And assume you're over here, which is J. Assume you're over here, which is G, correct? So what is J? J is at the 0 and 1 index. So if you're looking to make RO and you have exhausted, like this string doesn't exist, you have exhausted. How many operations will you require to make RO? Obviously 2 operations. Because if you don't insert RO, what am I saying? Let's understand what does this signify. F of -1 and 1, because this is 1, this is where the J is. That means minimum operations to convert an empty string, because -1 means you don't have any. Convert an empty string to a string from 0 to 1, which is nothing but RO. What are the minimum operations you'll take to convert an empty string to RO? Obviously, you require 2 insert operations. Can I say if string S1 gets exhausted, you end up returning J plus 1? Because if J is standing at the index 1, it will take 2 steps, 2 insert steps. So I can say can return J plus 1. That's how you have to analyze. Perfect, guys. So if this string gets exhausted, you have to return J plus 1. What about the other thing when S2 gets exhausted? Let's write it. If S2 gets exhausted, or exhausted, whatever you can call it. So imagine S1 is horse and Ravi is standing somewhere over here, which is 0, 1 second index. And S2 was, like you're standing at -1, there was ROS, which is 0, 1, 2. This is where J is. So what does this signify? F of 2, -1. What does this signify? Operations, minimum operations, to convert HOR to an empty string. How many operations? Oh, come on, guys, you can tell me. Obviously, you'll perform 3 delete operations, which means I plus 1 because you're standing at 2, so 3 operations. So can I say, if it happens the other way, which is if this gets exhausted, we'll say require I plus 1 operations. Perfect. That's how you write the base cases. And that's how you do this at a distance. Wow. Okay. So again, we are doing recursion. So we're trying all possible ways. So obviously the time complexity will be exponential. Because there are 3 states where you're calling, so it will go up to 3 to the power n into 3 to the power m. So we will not discussing that because it is a lot complicated. First piece complexity. Auxiliary stack space. Again, n plus m can go as, but that can be the auxiliary stack space. You have to see for overlapping subproblems. So if you try to draw the recursion tree where you are comparing, you will see overlapping subproblems occur. Try drawing the recursion tree by yourself, you will see there are portions where there are overlapping subproblems. So if there is an overlapping subproblem, what do? You tend to memorize. Is there even a doubt? Yeah, you tend to memorize. Just go across and try to memorize this. So try to memorize changing parameters. I and j, what's the maximum value of I? N, what's the maximum value of j? M. So n cross m EP is what you end up taking up. So in memorization, you know what to do. Just a couple of steps. Just make sure you, before returning, write it. And before coming over here, just make a check. If you're able to do this, I am successfully able to convert this into a time complexity of number of states, into a space complexity of the TP array plus an auxiliary stack space. Amazing. Wow. That's what the memoization time complexity will be. So let's quickly code this up. So you're given a string s1 and string s2. Let's find the size super quickly. str1 dot size. Let's find the size for m as well. str2 dot size. Perfect. And I think write the function. So int f I.
Okay, so bro, I wasn't thinking in that way. I mean, let me note down some marks first. First, let me solve it. So we have start. Let's say length of start is nothing but m. Then of s start m is m. Battery power is less than 5% dot. Hey bro, wake up. What the heck? Are you not going to do this? No problem. As you wish. Okay, let's solve it. M and N will be len of target, and what I'll do, define solve self M N start and target, and other than that you will be having memory. -1 -1 for underscore range m n plus 1 for underscore in range m plus 1, and here you will see return self solve m n start target memory. If condition, if m equals to 0 or n equals to 0, m equals to 0, that means length of first string is 0. That means you need to insert return number of characters remaining in that string n. If n equals to 0, that means no characters are remaining in the first string, so you will say return n0, no characters, so delete, insert, delete. target of n minus 1. If both are matching, do I need to do anything? So plus 2 0 plus OP1. So what you are doing? Replacing the character. So 1 plus self solve Can't we do it? Oh gosh. Okay, so this is one approach. Now I wanted to solve it using the tabular method. Solution for this one. Okay, what does 0 means? 0, 1, 1, m, n. So 0 means both has 0, then it will be 0. Okay, one has length, another one not. For example, n don't have any length, m don't have any length, n has. That means it is nothing but inside operation. So you will say 1, 2, 3, 4 dot 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 n. Here m have length, n don't have length. That means this is nothing but delete. 1, 2, 3 dot dot. Other options. What are the other options? If start of I minus 1 equals to both are matching, that means you will say what? Table simply just 1 plus, you will say table of zero, my bad. So you are option 2. I'm just writing down I minus 1 j, option 3 1 plus table of I and j minus 1. Let me tell you what exactly these are the operations that we are doing. Option 1, what you did, suppose you have a b c and here it is x y
Now what do? Simply you inserted y at this hypothetical situation. Inserted, so that is 1. Okay. Now what you will say? If it is matching, that means you will move this one, right? So you will say it will move. No, no. Replace. Just replaced. Sorry. C you replaced with y. I minus 1 j. Here what you did? I minus 1 means first string you just removed 1. Delete. Insert. And table of I j is nothing but mean of op1 op2. What is time right now? 6:40. 20 minutes I have. Now I'm just thinking like what are the options needed. So you can tackle this with previous array. This one, this is previous I minus 1 previous and current. So we can tackle it with only 2 lines of row, 2 arrays. So I'll do direct optimized one. I don't know what if you can see my face. Not needed, bro. So n is equals to, let's start with m. Len of start and m, n is nothing but len of target. Now previous will be 0 for what I'll do, I for I in range n plus 1, because these are the values that will be there. If m is 0, that means length of n, so it's good. Current will be having some issue if I'll use this, so I'll say 0 for underscore in range and range m plus 1 for I in range. Okay, I in range 1 to n plus 1, m plus 1 for j in range 1 to m plus 1. Current, first thing I will do, first current of 0 is nothing but the length of I, 1 2 3. So current of j, if s start of I minus 1 equals to target of j minus 1, then you will say both are matching, then current of j is nothing but 0 plus previous of j minus 1, else op1 current op1 1 plus previous of j minus 1, op2 1 plus previous of j, op2 op3 1 plus previous of j minus 1.
Really? No, no, no. Current of J minus 1. I minus 1 J. J minus 1. Okay. So these are the thing. And now you will say current of J is nothing but uh, mean of OP1, OP2, OP3. Pi then. Wow. List assignment index out of range. Okay. Let me see. Oh, the problem is here. And done, and I did it on time. But yeah, thank you. We'll see you. I'll see you in another stream. Bye bye. Take care. Okay, let's stop it.